here we had the collagen fibers, and we had some cells. The reticular lamina is that part up there where the red collagen fibers come up like the hooks on the Velcro. Together, these guys are basement membrane. This right here is areolar connective tissue. Areolar connective tissue has collagen fibers, right? The bacons. The bacon's reaching up. Bet you didn't know you could make bacon plural that way, did you? The bacons are reaching up to the fuzzies and connecting everything together. So they both are, that's basement membrane. That's what sticks the simple columnar epithelium to the areolar connective tissue to the stuff underneath, whatever it is. Does that make a little more sense?
Yes, the aerial CT is a type of particular lamina or
okay, reticular lamina is actually part of this interface. Think about reticular lamina as hooks on Velcro. Areolar connective tissue produces those hooks. This is all reticular lamina, only this is reticular lamina because it's interfacing with the basal lamina. That makes the basement membrane a structure. This whole thing is a tissue, that whole thing is a tissue. Better?
Yes.
I think you helped about 6 or 7 people looking around the room.
The reticular lamina rests on top, or is just all the way through and coming out of the.
Let's say like this. The reticular lamina is kind of, if this was a tissue, this would be the reticular lamina. Yeah, the hooks coming up. And the fuzzies would be like these, off that epithelial tissue, so it's kind of like this. That help? You probably helped a couple people too.
When you say fuzzies, does that mean the other part of the Velcro?
Yeah.
Okay,
The fuzzy part of the Velcro,
and
there's the fuzzies and the hooks.
and the hooks,
The
okay,
fuzzies is the basal lamina,
okay,
the hooks are the reticular lamina.
okay,
All right, how we doing, everybody okay?
yeah.
All right. Adipose connective tissue, you can see that on page 131 also. Adipose tissue stores lipids. So we could also say it stores energy. Stores lipids, stores energy. And if you look on page 131, location-wise, under the skin and subcutaneous tissue around the kidneys and eyeballs, abdomen, breasts, etc. Where you find adipose tissue. Areolar tissue you find underneath pretty much all of the connective tissue. It's also around capillaries. Reticular connective tissue, turn the page. Remember from lab, it looks like tree branches, right?
Yeah.
Those tree branches form kind of like an internal skeleton for solid organs. They provide structure. They provide structure for solid organs. They also provide a framework to support other cells. They also form a framework to support other cells. You find a lot of reticular connective tissue in the spleen, in lymph nodes, places like that. So those are all part of the loose connective tissue category. There's also dense connective tissue, and you can see that on 132 and 133. Dense connective tissue. Dense connective tissue has tons and tons of collagen fibers. Collagen fibers everywhere. Regular and irregular talks about the direction of the fibers. Regular and irregular talks about the direction of the fibers. In dense, regular connective tissue, they all run the same way. Dense, regular tissue. Fibers all run the same way. It looks kind of like the ocean. All the fibers are going the same way. So it'd be really strong in one direction, right? Be really strong in one direction. The other direction, not so much. When I say tendon, you guys know what I mean? Ever take apart chicken pieces and the little white things that look like almost like straws or little long things? You can split them right down the middle. They split pretty easy. It's really hard to pull them apart the direction the fibers go. Does that make sense to everybody? I said the word tendon, and you guys have also probably heard ligaments, right? You guys heard the word ligaments before? What's the difference between a tendon and a ligament?
The thickness?
Not thickness, it's good guess. Not thickness, go ahead.
A tendon connects muscle to bone and ligaments connect bone to bone.
Exactly, good job. Tendons connect muscle to bone. Ligaments connect bone to bone. If you didn't know that, write it down. You own a human body, you should know stuff about it. Tendons connect muscle to bone. Ligaments connect bone to bone. You're gonna have to know that in a week or two.
Those are dense regular fibers or regular dense?
Tendons are dense, regular connective tissue. So are ligaments. They're all going the same direction. Dense, irregular connective tissue, the collagen fibers go different directions. Collagen fibers are like crazy, this way, that way. As a result, dense, irregular connective tissue is strong in all of the directions. Let's see, not just one. Dense, irregular connective tissue is strong in all of the directions. You have dense, irregular connective tissue in the dermis of your skin. And capsules around joints. Dermis of your skin, capsules around joints. You have dense, irregular connective tissue. Both of those provide strength. Everybody all right? Cartilage. Cartilage you can pull on and push on it. Cartilage you can pull on it and push on it. It provides structure. It's stronger than the dense connective tissues, but it's not quite as strong as bone. I don't exactly like the way that came out. Cross that last episode. Last thing I set out. It's not necessarily stronger than or not as strong than. It's not quite as structural. Bone is solid. You can hang stuff off of it. Cartilage is kind of like not quite as solid as bone, but it's also a little squishy, so it's like a shock absorber. You have cartilage between your bones, so your bones can kind of do this. Cartilage acts like a shock absorber in between. Bones are really stiff. Cartilage isn't quite so stiff. Does that make sense?
Oh, yeah.
Dense tissue isn't stiff at all. So cartilage is kind of like in the middle. Everybody okay? All right. Cartilage is avascular. No blood vessels in cartilage. also no nerves in cartilage. Cartilage is not innervated. Cartilage is not innervated. If you take a look at page 135, there you'll see two kinds of cartilage. Hyaline cartilage is up the top of the page. Hyaline cartilage is the most abundant cartilage in the body. Hyaline cartilage is the most abundant cartilage in the body. Found a lot of places. When you're an embryo and then a fetus, it makes up most of your skeleton. It covers the ends of all of your long bones. Covers the ends of all of your long bones. Connects your ribs to your sternum. And makes up your nose, trachea, and larynx. If you're wondering where all that stuff is coming from, look at page 135 of the book, there's a big list. One of the things about hyaline cartilage, it has collagen fibers, but they're really small. They're really small. You can't really see them even under a microscope. I think they say in the book, other people say it looks like frosted glass. Not really sure I get that, but how many guys have had chicken wings or drumsticks before? You know the pieces on the ends, that's hyaline cartilage. Usually when you cook it, it's like whitish. That's hyaline cartilage. And it's positioned on the ends of bones. We have another name for it, it's called articular cartilage. We're gonna learn about articular cartilage after the test. But if this is a bone feature and this is a bone feature, they move together like this, both of these are covered with hyaline cartilage. Make it nice and smooth, and we call it articular cartilage because it's where the bones articulate. All right, we'll get it there. Elastic cartilage is kind of like hyaline, but it has extra stuff. You look on the bottom of 135 there, you'll see elastic cartilage. It also has elastic fibers. It also has elastic fibers. Of course, because it's elastic, it's nice and stretchy. Elastic cartilage is why your ear is nice and stretchy. You can smoosh your ear up and it springs back into shape most of the time. You can sleep on it at night and come back, pick your head off the pillow and it springs back to where it's supposed to be. Your epiglottis is also made with elastic cartilage. Your epiglottis is also made with elastic cartilage. How many of you think you have an epiglottis?
Everybody has it.
Yeah, everybody has an epiglottis. It's that little flap that covers your trachea when you swallow. It's supposed to keep liquids out and stuff like that. Pieces of food. Does it work all the time? No, not so much. You guys have all had something go down the wrong tube, right? Because your epiglottis didn't seal it. If you get into geriatric care, taking care of older people, it becomes a big thing. Because some of them lose their swallowing reflex and they have to drink this, drink this thick water. It's like Eve. It's almost like Jello water. Eve. Just don't get old. I figured out how to not do that. I think I'm already there.
Drop that.
Yeah, take chances. All right, so that's elastic cartilage. Turn the page. And there is fibrocartilage. Fibrocartilage has a lot of collagen fibers. Fibrocartilage has a lot of collagen fibers. It kind of looks like the sky when they stain it with that blue color. I think it looks pretty cool. Page 136. You find fibrocartilage places like the meniscus of your knee and intervertebral discs. meniscus of your knee, intervertebral discs. Or you guys know somebody who has a torn meniscus in their knee? Yeah, it's not fun. Not fun. What they'll do is sometimes they'll get in there and cut that piece out and put some cadaver tissue in there. Dead people. Those places. You have one?
Oh, yeah, but that's not what I was gonna
Okay.
ask, but never mind about my
Alright,
question.
okay. A buddy of mine has one of those, he's got a dead guy's knee. Supposedly, so the story goes that his donor was killed by lightning, and now every time it starts to thunder, he wants to run. I don't know. Probably not the truth, that's alright, it's a good story he likes to tell. Also between your intervertebral discs. What do you mean intervertebral disc? What are we talking about here?
In between.
Just between the vertebrae. You know somebody who has a bulging disc? That's one of these. That disc bulges out and pushes against the nerve. It's really painful. Really painful. Oh, by the way, speaking of bulging discs and pain management, there's a new series on Netflix called The Pharmacist. I've watched the first two, I haven't watched the second two, I watched the first two last night. Kind of interesting, it's about this one dude's battle against Purdue Pharmaceuticals and the pill mills that were operating 5-10 years ago that got everybody hooked. It's still killing thousands of people every day. I don't know thousands, but hundreds of people every day here in the US are dying from opioid addiction because all this happened. So if you got Netflix, check it out, it's interesting so far.
What is it called? Pharmaceutical?
It's called The Pharmacist. Purdue Pharmaceutical is the name of the company. They're out of business now. And the owners got busted trying to transfer $10 billion out of the United States so they could declare bankruptcy. Anyway. That's fiber, cartilage, intervertebral discs. Bone, it's also called osseous tissue. Bone has lots and lots of collagen in it. That makes it strong. Bone is very vascular. The extracellular matrix gets calcified. Calcium salts get dissolved in there and makes it hard. How many guys have touched a real human bone? You get to do that in lab. We got real bones down there. You'd be surprised how light they are, and it doesn't feel like you would think. It's kind of cool. And then blood, they also call it vascular tissue. Please note, this is not blood vessels. This is the stuff inside. This is just blood. That is a connective tissue. That is a connective tissue. Because it cells in an extracellular matrix. If you take a test tube full of blood and spin it down, all the red blood cells go to the bottom of the cell and you get the straw-colored stuff up top. That's plasma. That's the liquid part. So the blood that comes out, it looks bright red. Oh, look, it's bright red. But if you spin it, it separates out into its various components. We'll learn that name too. But blood is a connective tissue because it cells in a matrix. Everybody all right? Questions?
Is the plasma the extracellular matrix?
Yes. Yep. It's got dissolved proteins. It's got all kinds of stuff in it. It's actually almost like a gel because there's some clotting proteins in there. You don't want it to clot, but it's kind of like a gel. All right. Next up, epithelial membranes. Epithelial membranes make up coverings and linings. Epithelial membranes make up coverings and linings. Take a look at page 141 in your book. Epithelial membranes are made of an epithelial tissue plus a connective tissue. An epithelial tissue plus a connective tissue. That is an epithelial membrane. Epithelial membranes equal epithelial tissue plus connective tissue. Got three different types of membranes. Page 141, you can see cutaneous membrane. That's a fancy word for your skin. That's a fancy word for your skin. The tissues involved: stratified squamous epithelium, and dense irregular connective tissue. There's others, but those are the two different. Stratified squamous epithelium and dense irregular connective tissue. Did we talk about the difference between keratinized stratified squamous and non-keratinized stratified squamous?
Yeah.
A little bit maybe? Yeah. Stratified squamous in your skin is keratinized, it's dry. The outside of your body. So cutaneous membrane is keratinized stratified squamous epithelium plus dense irregular connective tissue. Outside of your body, skin, dry. Also on page 141, mucous membranes. Mucous membranes are moist. Mucous membranes are found in body cavities that are open to the exterior. Mucous membranes are found in body cavities that are open to the exterior. Someplace you could touch if you had a really, really long finger. The whole way through your GI tract, all the way down into your lungs, all the way up your urinary tract. All those places are mucous membranes.
How about your mouth?
Yep, definite mucous membrane. Inside your mouth, there is stratified squamous epithelium, non-keratinized. Inside your mouth, is stratified squamous epithelium that's non-keratinized. Same thing for vagina and anus. They're all stratified squamous epithelium. They're all non-keratinized. Other places, the epithelial tissue can be a little different. The epithelial tissue through your GI tract is mostly simple columnar. The epithelial tissue in your lungs out in the ends is simple squamous. The connective tissue associated with all of those guys is areolar tissue. So mucous membranes have areolar tissue. And on top of that is either stratified squamous, non-keratinized, simple columnar, simple cuboidal, simple squamous. So the epithelial tissue varies depending on where in your body it is. Connective tissue is areolar tissue. Those are all mucous membranes, open somehow to the outside. Theoretically, your GI tract is open the whole way through. You got a mouth at one end, the anus at the other end, but it's a big long tube. And then if you turn the page to 142, now you can see the serous membrane system. Serous membrane system. That's in cavities that are closed, not open to the outside. Closed, not open to the outside. That is simple squamous epithelium and areolar tissue. That's simple squamous epithelium and areolar tissue. It's also wet. And you guys know all about visceral and parietal flora, visceral and parietal pericardium, visceral feral peritoneum, right? You know all those?
Sure.
You need to. need to. All right, everybody good? Nervous tissue and muscle tissue. I'm going to give you some very rudimentary functions and characteristics, etc., types. Straight up, not on the test. Because this semester we're going to get deep into nervous tissue and deep into muscle tissue, and we'll do that after the test. Alright, just write down what I say. Don't spend a lot of time on it. Nervous tissue function transmits and stores information. Transmits, stores information. Characteristics: contains branching cells that can conduct electrical impulses. Contains branching cells, conduct electrical impulses. Cell types: you have neurons. You guys have all seen a neuron before, right? Yes, no, maybe? That's one of the things I can draw that actually sort of looks like what I'm trying to draw. So, one of those for you. There's a neuron. Big, long cells. This sounds really cool. They're amitotic. They don't divide. I think we talked about this before. You have the same neurons you were born with, and you're going to die with the same neurons. Same cells. You have neurons in your body that are this long. A single cell this long. It runs from your sacral region all the way down to your toes. What nerve am I talking about? Anybody know? Sciatic nerve. Yeah, it's your sciatic nerve. You got cells this long in your body. Those are neurons, and supporting cells help the neurons do their job. That's all we need to get into for right now. Muscle tissue function, it contracts. That's all muscle tissue does, it contracts, it gets shorter. Stretches out again. But that allows us to move things. That allows us to move our body around. That allows us to write notes. It also pumps our blood and moves lunch through your GI tract. The muscle tissue moves material, moves people.
Say pumps blood and what else?
Pardon?
You said pumps blood and
And moves lunch.
lunch.
Did you eat breakfast? Okay, it's moving your breakfast through your GI tract.
Okay.
It's in your stomach right now, it's moving into the small intestine. It's gonna be large intestine, and it'll be out. Characteristics: muscle tissue is very cellular, and it's very vascular. Muscles burn a lot of energy, they need a lot of blood flow, they need a lot of oxygen. Types of muscle tissue: skeletal. Take a wild guess and tell me what skeletal muscle is attached to. The skeleton. Almost all the time, almost all the time. Contracts and makes you move. It is voluntary. What does that mean? Yeah, you think about it and do it. It's also striated. Striated means it has stripes. Where do you think you find cardiac muscle? Heart. Cardiac muscle is also striated and it has stripes. And we'll see those later on this semester. But it's involuntary. Can any of you guys stop your heart for a while? Don't try it. Don't try to do that. Yeah, don't do that. If you practice, if you do a little biofeedback, you can slow your heart rate or speed it up when you're scared. Go ahead.
Is cardiac muscle also found in the blood vessels?
question is just the heart. Just the heart. Good question. Smooth muscle has no striations. That's why they call it smooth. It's also involuntary. Can any of you make your stomach roll right now? Probably not. That's the kind of muscle that's in the blood vessels. Smooth muscle. Why in the world would you need muscles in your blood vessels? Good guess. Yes. Vasoconstriction and vasodilation. Vasoconstriction and What in the world is vasoconstriction? When the blood vessel goes like this, it gets smaller. Vasodilation, it gets bigger. Why in the world would you want blood vessels to get smaller and bigger? Yes, that's one. Good. But there's a bigger one.
Control the pressure.
Yeah, good job. Control your blood pressure. If you make your blood vessels go like this, what do you think happens to your blood pressure? It goes up. Or it goes down. It also controls the blood flow to different areas of your body. That's Pt.2. But that's smooth muscle. Around hollow organs like your GI tract and blood vessels. All right, now, tissue repair. This is on your test. I'm going to show you a little video. Take a look at page 143 in your book. Couple things I want to get straight with you guys. In your notes it says, inflammations. That is not a part of tissue repair. That's getting ready for tissue repair. We say it sets the stage. You're not actually fixing anything, but you're getting ready to. You're not actually fixing anything, but you are getting ready to. Here's another general knowledge question. You guys may or may not know this. What are the 4 cardinal signs of inflammation?
Swelling.
Redness? Yes, beautiful, good job. Swelling, heat, redness, pain. If you did not know that, write it down. Once again, you own a human body. You need to know this stuff. Swelling, heat, redness, pain. You guys ever get a splinter that gets infected? You know what I'm talking about. You guys ever twist your wrist, twist your ankle, stove your thumb, something like that? It gets all red and puffy and hot and it hurts. That's inflammation. That's inflammation. You ever get bitten by a cat? And the next day you get little red stripes coming up your arm? Go to the hospital now. Do not go to the doctor's office. Go to the ER now. Because you can die from it. Cats have filthy little mouths. They do. And if you get an infection, if you get any kind of infection that you see little red stripes coming up your arm, go to the hospital. Don't go to the doctor, go to the hospital. Alright, because that infection can kill you quick. But if you get a regular little thing and it's all red and puffy and it hurts, that's inflammation. That's your body trying to fix stuff. Alright, now this one here, the little 2-minute jobby, that's something that I would show you. But I see this, 6 minutes. You want to shot at this just for fun, I'm not showing you the hour and 11 minute one. Well, that's sound bath healing. Ooh, by the meditative mind, yeah, that sounds like a real thing.
Very scientific.
Yeah. Yeah, don't believe everything is getting into that. Let's see what this one's like. I will bail on this heartbeat. It scares me down here. What do we do whenever the computer gives you a problem?
Turn it off, turn it back on.
Turn it off, turn it back on again. Watch, there's gonna be a major update now too. We're using different search terms, so we're getting different results. That's all right. Oh, look, 14 seconds, that'll work. Why is it not? Let's try it. What do you say? Oh, this is just gonna be pictures.
Okay, in this video, we're going to talk about tissue repair development.
Oh, this pay site, watch, it's gonna say, you gotta join. Second phase.
Well, whether it's due to sports or a medical problem or maybe an accident, like a fall down some steps, you might get a nasty wound. A wound is just an injury to an organ or tissue of the body that results in a disruption of the normal continuity of that organ or tissue. That's a mouthful, but I know you can relate to this because you've certainly had a wound on your skin before. The skin is an organ of your body. The wound, let's just say it was a cut, disrupted the normal cohesion or unity of the skin. The skin was broken, and that's what I mean by a disruption of normal continuity. That wasn't hard to understand, was it? Probably not. In that case, let's move on to the 3 phases.
Is this guy really annoying? Or is it just me?
Of wound healing. I promise I'll make it easy on you. The first phase of wound healing is the coagulation or inflammatory phase, or just both coagulation and inflammatory phase. Sometimes this phase is actually split into 2 separate phases. However, it's easier to combine it into one because both of these aspects of this phase start to occur at pretty much the same time. Coagulation is another word for clotting, and inflammation is a local protective response to an injury that helps to dilute, destroy, or wall off the injured tissue or the agent responsible for the injury. Important signs of inflammation include pain, redness, heat, swelling, and in some instances,
Anybody know the 5th one? Loss of function. If you twist your ankle, you're gonna walk on it, you're gonna avoid it, or try to anyway.
a loss of function of the area in question. What happens in this case is as follows. After you cut your skin, the broken blood vessels of the skin begin to gush out blood. Not good. The body does not want to lose blood. That's why platelets, cells that plug up holes in blood vessels, stick to the damaged blood vessels and initiate a cascade of steps that result results in the clotting of blood. The clotting of blood plugs up the holes in the bone.
I knew that was tough. These guys suck. Sorry. Oh, this was gonna be terrible too.
Every musculoskeletal injury goes through 3 important stages of healing, which are inflammation, repair, and remodeling. Inflammation is the body's emergency response and begins immediately after an injury to fight the most dangerous effects. This causes swelling, redness, and pain for 3 to 5 days. With inflammation, no time of the day or night is pain-free. If rest or changing position reduces your pain, then the injury has moved to the repair stage.
Okay. So, what I want you guys to know, beside inflammation, write this down. Inflammation sets the stage for healing. It gets ready for healing. Inflammation is going to increase the amount of fluid in an area. And it's going to call cells to the area. It's going to say, hey, we need help here. We need more cells. There's chemical messages released that say, we need help. So inflammation increases the amount of fluids. It's going to bring cells into the area. It's going to bring macrophages. What do macrophages do? They eat stuff. They're going to eat any busted up cells or any damaged tissue or anything like that. It's also going to bring mast cells to the area. Now, I forget if we talked about that in lecture lab. But you guys know mast cells do what? Yeah, good. They release histamine. Mast cells release histamine. What does histamine do? It causes inflammation. So that gets things ready to start repairing the tissue. They're not actually repairing the tissue. Inflammation is not a part of tissue repair. It gets ready for tissue repair. Comfortable?
Cellular level, inflammation attracts specialized cells called fibroblasts, which spin webs of connective tissue to bind the wound together, similar to the scab on a scratch wound. This limits the flow of fluids, protects the injury, and begins repair.
Okay. Organization. Organization is the start. Organization is going to restore the blood supply. Fix the broken blood vessel or fix the broken capillaries. It's going to bring fibroblasts into the area. Actually, the fibroblasts that are there are going to start multiplying rapidly. So you'll have more fibroblasts. What do fibroblasts do? Make fibers. What kind of fibers? Collagen fibers. Collagen fibers, what can you tell me about them? They are strong, so they're going to make connections and they're going to seal up the cut. Kind of like stitching it with collagen fibers. Stitch the cut shut. Careful not to say bad word. You also form granulation tissue. You also start to form granulation tissue. Granulation tissue is really important for healing, tissue repair. Granulation tissue. They call it granulation tissue because it looks granular, bumpy. The reason why it looks bumpy is because there's lots of brand new capillaries there. There's lots of brand new capillaries in granulation tissue. Guess what the new capillaries do? They reestablish the blood supply. Yeah, they reestablish the blood supply. Now you can get blood back into the area. And you need blood because you got a lot of growing cells, right? You got a lot of fibroblasts making collagen. They all need energy. They need nutrients. They need amino acids and stuff like that. So the granulation tissue brings all the capillaries back and it's going to feed everybody. So you got fibroblasts multiplying, making collagen fibers. You got granulation tissue forming, reestablishing the blood supply. That's organization. How do we feel about that? Okay?
Food supplements can be used to help this process by supplying the body with the nutrients it needs to heal and keep the inflammation at a healthy level. These include omega-3 and omega-6 fatty acids found in vegetable oils like flaxseed and fish oils, and antioxidant nutrients such as vitamin C, E, selenium, and bioflavonoids.
I'm just waiting for there to be an advertisement, or you can buy our pill.
The standard treatment for acute injury is rest, ice, compression, and elevation.
You guys knew that, right? Right? Rest, ice, compression, elevation.
Because they've kind of studied and changed that now.
What are they saying now?
Mostly it's heating the area to increase the blood flow. As long as you control inflammation, that ice actually.
Well, ice at first, ice for the first 24 hours, and then,
Yeah, because ice can actually slow down the healing process.
Exactly, I totally agree with you, yeah. You ice first to help control the inflammation, to reduce inflammation, ice for the first 24 hours, and then heat. And that will vasodilate, bring more fluids in, and reduce inflammation, and increase the healing process, absolutely.
Also known by the acronym RICE. Rest prevents further irritation and injury.
So, regeneration and fibrosis. Regeneration is renewal of the epithelial tissue. Regeneration is renewal of the epithelial tissue. If you're not already there, you should be looking at page 143. The epithelium regenerates and connects together, and fibrosis is formation of scar tissue. Fibrosis is formation of scar tissue.
Floheim had always been a tall girl. I mean, technically, we're all just meat.
He
You
goes,
guys know this, right?
he goes too fast.
Crash Course? How many
Yeah.
guys are watching Crash Course? Yeah, definitely, check it out.
Yeah, he goes too fast though.
Yeah,
you gotta watch it several times.
Ligaments, which bind bones together anywhere you got a joint. And durable, but cells surrounded by an extracellular non-living matrix. In this case, the ground substance is your blood plasma.
Try to see if you
Chaotic cafeteria packed with middle schoolers, we'd be hopeless messes without our hierarchy of org.
Okay, he doesn't have anything else to do. Are you guys comfortable with this? You okay with the healing process? Inflammation sets the stage, organization, formation of granulation tissue, more fibroblasts making more collagen fibers. That sews everything up. And then regeneration, the epithelial tissue covers it up again. Fibrosis, you might make some extra collagen fibers, maybe a little too many collagen fibers, and that leaves a scar. The scars are kind of cool because they're stories, right? How many guys like your scars? They're well earned. You should be proud of them. Questions? Yes.
Just out of curiosity, what makes like different parts of the body, coagulate like the pedal bleed longer than like the body?
Okay, what you're seeing there, if you guys notice, scalp injuries bleed a lot, because there's lots of capillaries there. Really rich blood flow. Other places, there might be more adipose tissue, and it's not so rich in blood. That's gonna, so you, head injuries, it looks like you've been murdered by an axe. You know, you hit your scalp, blood everywhere.
So it's not that there's like more or less platelets or something.
No, you got the same amount of blood throughout your body. You just opened in more blood vessels, so it's gonna take longer to fix it. Good question. Other questions? Over anything at all? Doesn't have to be anything we talked about today. Anything you don't understand? Let's pass it to test.
What is the easy way or, fast way to find the definitions for the visceral flora and visceral pericardium? Because in the book, it just kind of glances over the serous membrane.
I'll draw them for you, how about that? Or, some old quizzes from us 2 semesters ago. Visceral flora, sorry, visceral and parietal membranes make up a serous membrane system. All right, serous membrane system, 2 of them, visceral and parietal. Visceral is stuck to the organ. It's part of the organ. Visceral serosa is part of whatever organ you're talking about. Ooh, quick as a side note, I might not explain this very well. It's gotta be in the ventral body cavity to have cirrhosis. The brain and spinal cord do not have cirrhosis. There's other membranes. So, ventral body cavity. Visceral is part of the organ. Parietal lines the cavity. Visceral is part of the organ. Parietal lines the cavity. Now they're named for where they are, or what they're covering. There's a heart. Heart goes in the pericardial cavity, right? The visceral membrane is literally part of the heart. It covers the heart. So this is the visceral pericardium. Visceral pericardium. This here is the pericardial cavity. Everybody see? You know what I'm pointing at? This is the parietal pericardium. It lines the cavity. Together, that's the serous membrane system. Visceral on the organ, parietal lining the cavity. In between them is a space filled with serous fluid. That serous fluid acts like lube. Make sure everything can move nice and smoothly against each other. If you've ever seen Discovery Health, where they crack open a chest, the heart's in there, it's really torquing pretty good. So you need to have something so it can slip and slide. That's visceral and parietal pericardium. Visceral and parietal pleura are going to be around the lungs. That's in the pleural cavity. Visceral and parietal peritoneum are going to be down here in the abdominal pelvic cavity. Like the stomach could have visceral peritoneum on the outside. Parietal peritoneum is lining the abdominal pelvic cavity. Better?
Yes.
Cool.
What is this cavity called?
This is pericardial cavity. Lungs are in pleural cavities. Down here is abdominal pelvic cavity. Peritoneum. Good question. Thank you. Others? Anything? Day 1.
Are we gonna really need to know like what the polymers are and stuff?
That falls in the category of, so that's the question about what was done.
Okay.
Sorry. let's say that's a glucose, monosaccharide, right? Monosaccharide, one ring. That's a monomer, okay? One glucose. Now, if I stitch 5 of these guys together, four of these guys together, that's a polymer. Each one of these is monomers. Each glucose is a monomer. But I got 4 of them in a row. Poly's many. So I got 4. If I had 100 of these, what would this be? You should know this molecule. If I had 100 of them, what would it be? Yes, good, glycogen. Glycogen is a storage form of glucose, right? One glucose. You got all of them, it's glycogen. This was an amino acid. One amino acid, that'd be a monomer. It's easier to draw, so I'll make more. All together, call it a polymer. And since those are amino acids, this would be, yeah. Polypeptide, if you want to be really fancy. Protein if it was longer. Don't worry about the difference between polypeptide and protein, I'm not gonna ask you that. Polypeptide is like 8, protein is like 47. Go ahead.
I had a question. Today in this class I had someone's notes, and it said oftentimes hormones are protein, which means they are held together by polar covalent bonds. When do you call that? Peptide bond?
Okay, a peptide bond is, you're correct. A peptide bond is a specific kind of bond between amino acids. They are, however, polar covalent in nature.
Oh, okay.
That helps, right? Good. Absolutely. More questions? These are good. I can't write to start skin now. All right, you guys, any more questions? All right, do you want to know what's on the test? I highly recommend you record this. Because after today, do not come and ask me, what do you mean by this? We said this was going to be on the test, can you explain this to me? After I do this, you guys are on your own, fly me free little birdies, got it?
Yes.
You did this once, I'm not going to repeat it, I'm not going to clarify it. Got it?
Got it.
Do not come back to me and say, it's not fair, you didn't say this was going to be on the test. I'm not telling you everything that's on the test, I'm giving you highlights. Do not come back and say, it's not fair, you didn't tell us this was going to be on the test. I'll stop doing it. Because I want to be fair. By the way, it's not fair, it never works with me. Do not try that. Everybody good? I highly recommend you take every sentence I say, write on the top of a piece of paper, and go through your notes and write down everything you can about that sentence that I said. That will give you one heck of a study guide. All right? I'll do this for every test. Unless you guys pester me about it. What's going to be the test? No. I'll tease you and torment you if you do that. This is your test. Levels of organization in the body. Couple questions about positive and negative feedback. And of course, homeostasis. organs are located in what cavities? Functional characteristics of life and survival needs. DNA structures and what those structures do. There are several questions about the organic molecules we studied. Carbohydrates, lipids, proteins. Questions about them structurally and functionally. A couple questions about chemical bonds. Simple questions. Good. Rule of octets. pH. Levels of protein structure. Different kinds of RNA. Hypertonic, hypotonic, and isotonic. Several questions about organelles and their functions. Cell junctions. Mitosis. Active and passive transport. Cell membrane, structure function. Cell membrane protein, structure function. Some questions about tissues. You know, what's in the matrix? What structures are in the matrix? Which tissues are vascular? Which are avascular? Characteristics like that. Question about the different cartilages. Several questions about epithelial tissues. Both the tissues, where you find them in the body, and what they do. Same thing with connective tissues. Structures in them, where you find them in the body, and what they do. Different types of glands. Sorry, different types of, I don't want to put this without telling you what the question is. Endocrine and exocrine glands. Endocrine and exocrine glands. Couple questions about tissue repair. And today is a good day to be in the front row because there are two matching questions about chemical structures. questions, multiple choice, bring a Scantron. Slide B3.